Okay, uh, let's start with some basic Java concepts. So, can you explain the difference between double equal to and equals method in Java?
Yeah, sure. The double equal to operator checks for reference equality, which means it determines if two reference points to the same memory location. For example, when comparing two object references using the double equal to, it will return true only if both references point to the exact same object in the memory. Okay, the equals method, in the other hand, is used for logical equality. It checks if two objects are logically equal based on their state, right? So by default, the equals method in the object class behaves like double equal to, but many classes such as string, integer, and custom classes override this method to provide a more meaningful comparison based on the object's data. Okay, so for instance, two string objects containing the same sequence of characters would be considered equal when using equals, but not necessarily when using double equal to. Yeah.
Hmm. Okay. So, can you tell me what happens if you override the equals method but not the hash code method?
Yeah, if you override equals method without overriding the hash code method, it can lead to issues when your objects are stored in hash based collections like hash map, hash set, or hash table. Okay, so according to the contract, so uh, according to contract defined in object class, if two objects are considered equal by the equals method, they must also have the same hash code. Okay, so failing to maintain this contract means the two objects that are equal according to equals might be placed in different bucket in the hash table, which can lead to unpredictable behavior. For instance, if you might not be able to retrieve an object from the hash map even though it appears to be present based on the equals method. Okay, so therefore it is crucial to override both methods to ensure consistent behavior when objects are used in hash based collections. Yeah, so uh, that's the problem when we are, I mean, overriding equals method but not hash code method.
Okay, so can you explain what is a Java class loader?
Yeah, a Java class loader is a in Java is part of the JRE, Java runtime environment. So this is responsible for dynamically loading Java classes into Java Virtual Machine (JVM). So it loads class files at runtime rather than at the compile time. So allowing Java to support dynamic and flexible applications. Class loaders follow a hierarchical delegation model. When a class loader is asked to load a class, it first delegates the request to its parent class loader before attempting to load the class itself. This delegation helps to ensure that classes are loaded in a consistent and controlled manner. The main type of class loaders are like bootstrap class loader, extension class loader, application class loader. So like bootstrap, we can be found in Java home and lib directory, and similarly extension class loader can also be found at Java home lib, and I think in the extension I think we can find that. Okay, so yeah, so understanding the class loader is important for tasks like class loading in large applications, dynamic loading of modules, and dealing with class path issues. Yeah.
Okay, uh, can you tell me the difference between array list and linked list in Java?
Yeah, ArrayList and LinkedList are both implementations of list only, list interface, but are backed by different data structure and have distinct performance characteristics. So in ArrayList, so it internally uses dynamic array to store elements, while in linked list, it internally uses a doubly linked list uh, where each element contains reference to both the previous and next node. Okay, and then again in array list, it provides fast random access to elements. So it is like array list is better for scenarios where read operations are more frequent than write operations, and whereas linked list, it is better for scenarios where write operations are more frequent than read operations. So can you explain what happens when a Java program is compiled and run? Java program is compiled and run. Yeah, when a Java program is compiled, the Java compiler converts the source code written in .java file into bytecode. So that is stored in .class file. So bytecode is an intermediate platform independent code that can be executed by the JVM. The process of running a Java program involves separate steps, so like loading, linking, initialization, and then execution. So these are the steps which are involved. So yeah, so on the very top level, so this is how um, I mean Java program is compiled and run. Yes.
Okay, can you describe what the transient keyword does in Java?
Yeah, the transient keyword in Java used to indicate that a particular field should not be serialized. Serialization is the process of converting an object state into byte stream, which can be stored or transmitted and later reconstructed. Okay, so when an object is serialized, all of its fields are typically included in the serialized representation. However, fields marked with the transient keyword are executed from the from this are sorry are excluded from this process, so this is useful for fields that contains sensitive information like password, or fields that can be derived from other data and do not need to be saved. Okay, so so for example, suppose we have a username password like that, right? So password we can make it transient. Okay, so this will not be, so that password will not be serialized. Yeah.
So, can you tell me what a future and callable are in Java and how they are related?
Callable and future. Okay, so callable and future are part of, I think, Java util concurrent package, so which provides a framework for handling concurrency. Uh, uh, Coming to callable, so callable is a functional interface similar to runnable, but it can return a result and throw a checked exception. It has single method called call. Okay, so this returns a value of type v. This makes callable more versatile than runnable, so which cannot return result or throw checked exceptions. So coming to future, so future represents the result of an asynchronous computation. It provides method to check the computation is if the computation is complete, to wait for its completion, and to retrieve the result. So we get a future object when we submit a callable task to a executor service. So future object allows us to manage asynchronous task and retrieve the result once the computation is done. It also provides the method to cancel the task or check if it is done, adding flexibility to concurrent programming in Java.
Okay, can you explain the final keyword in Java?
Yeah, final keyword in Java can be used in like three different contexts. So either it can be used with variables, or it can be used with methods, or it can be used with classes. Okay, so whenever a variable is declared as final, so its value cannot be changed once it is initialized. Okay, for instance, a final primitive variable or a reference variable once assigned a value, it cannot be reassigned. Okay, so that's the case with the final variable. So coming to final method, when a method is declared as final, it cannot be overridden by subclasses. So this is useful when you want to prevent any subclass from modifying the implementation of the method, ensuring consistent behavior across the class hierarchy. Okay, then coming to final keyword with classes. So when the class is declared as final, it cannot be subclassed, you know. So this is often used for security reasons or to provide immutable implementations, so as seen with the string class in Java. So the final keyword helps in defining constant, preventing inheritance, and ensuring method implementations are not altered by subclasses.
Okay, then what is a static block and when it is executed?
Yeah, a static block, also known as a static initializer. So it is a block of code that is executed when the class is loaded into the JVM. So it is used to initialize static variables or perform any static initialization required by the class. So a static block is executed only once when the class is first loaded, before any instance of the class is created, and before any static method are accessed. So if there are multiple static blocks in the class, they are executed in the order they appear in the source code. So static blocks are useful for initializing static variables that require complex logic, or for performing one-time setup action that apply to the entire class.
Okay, then now can you explain what is volatile keyword and when it should be used?
Yeah, sure. The volatile keyword is in Java is used to mark variable as being stored in the main memory. When a variable is declared as volatile, it ensures that any read or write to that variable is directly from or to main memory, not from the thread's local cache. This is important in multi-threading environment mostly, where multiple threads might be accessing and modifying a shared variable. Without volatile, a thread might read a stale value from the local cache, leading to inconsistent and unpredictable variable. Using volatile, it guarantees visibility of changes to variable across the threads. When one thread updates a volatile variable, the changes is immediately visible to other threads. However, it does not guarantee atomicity, meaning operations like incrementing a volatile variable are not thread safe by themselves. Yeah.
Okay, so as you said, the volatile keyword has atomicity issue, right? So can you explain how to maintain atomicity when working with volatile variable and that keyword should be used to ensure atomic operations?
Yeah, sure. Volatile keyword in Java ensures visibility of changes to variables across threads, but it does not guarantee atomicity. So atomicity means that a sequence of operations is indivisible, that is, the operations are complete without interruption. Okay, to ensure atomicity in operations involving volatile variables, we should use synchronized keyword or classes from the like or like Java util.concurrent atomic package. So using synchronized keyword can be used to make sure only one thread can execute a block of code at a time, so thereby ensuring atomicity. When a method or a block of code is synchronized, the thread holds the lock, preventing other threads from entering the synchronized block until the lock is released. Okay, and using the atomic also, so so the atomic package provides the class like atomic integer. Okay, so we can use that class. So this classes internally uses low level atomic machine instructions, ensuring atomicity and better performance in highly concurrent scenarios. Okay, so yeah, so these are the two ways how we should achieve this.
Okay, can you explain what Spring Boot is and how it differs from the traditional Spring framework?
Yes, sure. So Spring Boot is an extension of the Spring framework that simplifies the development of standalone production grade Spring applications. So it is designed to reduce the boilerplate configuration required for the setting up a Spring application. So there are some key differences between the Spring and Spring Boot. So Spring Boot supports auto configuration. So Spring Boot automatically configures Spring and third-party libraries based on the dependencies present in the class path. So this reduces the need of manual configuration. In case of Spring Boot, it comes with some embedded servers like Tomcat, Jetty, and there are some others also I think. So this allows developers to run applications directly without needing a separate server installation. This makes it easier to package application as executable jars. So we don't have to separately go and install the servers. Okay, so Spring Boot also provides a set of starter project object models. So that includes common dependencies for various types of applications. For example, Spring Boot Starter Web. So this includes all necessary dependencies for building the Spring web application. Okay, and Spring Boot includes features like health checks, metrics, and externalized configuration to help developers to build production ready applications quickly. Okay, so like Actuator and all we can use. So we can simply give /health and it will tell the health of the application. So separately we don't have to go and configure it. So yeah, so that's so in summary, like Spring Boot streamlines the development process by providing sensible defaults and automatic configuration, which contrasts with the more manual setup required by the traditional Spring framework.
Can you explain how Spring Boot handles dependency injection and how it is beneficial?
Yeah, sure. So dependency injection is a design pattern used to implement inversion of control IUC, so allowing the creation of dependent objects outside of class and providing those objects to the class. uh, Spring Boot leverages the dependency injection pattern through the Spring Framework's IUC container. So there are certain benefits of dependency injection in Spring Boot. So, for example, loose coupling. So, dependency injection promotes loose coupling by removing the responsibility of managing dependencies from the classes themselves. This makes the code easier to test and maintain. Yeah, and also the testability, by injecting dependencies, it's easier to mock or stub these dependencies during unit testing, so which leads to better test coverage and more maintainable test. Okay, and configuration management also. So Spring Boot uses annotations like add component, add service, add repository, add controller to automatically detect and register beans in the Spring context. So this reduces the need of explicit XML or Java based configuration. Okay, and then Spring Boot simplifies the creation and wiring of beans using annotations like at the rate of auto wired to inject dependencies. The auto wired annotation can be used on constructors, fields, or setters method to inject dependencies. Yeah.
Okay, can you describe how Spring Boot manages application configuration, particularly with the application.properties or application.yaml files?
The Spring Boot manages application configurations through properties file, typically named application.properties or application.yaml. These files are used to define configuration settings in a centralized and externalized manner, making it easy to manage different configurations for various environments.
Okay, can you explain how Spring Boot handles security, particularly with Spring Security?
Yeah, sure. Spring Boot integrates seamlessly with Spring Security to provide robust security feature for applications. Spring Security is a comprehensive security framework that handles authentication, authorization, and other security concerns. So Spring Boot automatically configures Spring Security based on the dependencies present in the class path. This includes basic security setup like login and HTTP basic authentication.
Okay, can you explain what is Spring Boot Actuator?
Yeah, Spring Boot Actuator provides production ready features to help monitor and manage Spring Boot applications. So as I told you, like health is one of the way how we find out the health of the application. Okay, so Spring Boot Actuator, it includes various endpoints that exposes operational information about the running application. So they have various endpoints. For example, health is there, and then they have metrics, they have info, they have environment. So like that. So matrix exposes the matrix like memory usage, CPU usage, and request counts. And then similarly, info is there. So info displays attribute application information such as build details. Then coming to environment, so that exposes the current environment properties. So we can also have the custom endpoints. So we can create custom actuator endpoints to expose additional information specific to our application. And then for security, actuator endpoints can be secured with Spring Security to ensure that sensitive information is not exposed to unauthorized users. Yeah.
So, can you explain how can you enable the actuator?
Yeah, to enable the actuator, I think in Spring Boot, so we have the Spring Boot starter actuator dependency. So that we can add to our pom.xml, and also in the application.properties, we can give the like properties we can include there. So that's how it will be available to the user.
Okay, can you explain how to handle exceptions globally in Spring Boot application?
Yeah, in Spring Boot application, we can handle exceptions globally using, I think we have controller advice. So we have add controller advice and add exception handler annotations. So this allows us to centralize our exceptions handling logic and apply it across all controllers. So these annotations we can use. So like first of all, we create a global exception handler class, and then we define the exception handling method. So for example, class we can say add controller advice, and under that we will have the method called add exception handler. So means that tag will be there on top of the method, and then we can customize our response. So in the exception handling method, we can customize the response returned to the client, such as setting HTTP status code and returning some custom error message. So those things we can do. Yeah.